Hey everyone, in today's video we're going to be talking about piecewise functions. So we have a graph over here on the left, and as you can see the graph looks a bit different. For one, it's not all connected. It's not a continuous loop like this or this or this. It sort of has breaks in between each of the lines in the graph, and some of them have like circles on them. Some of the points are just circles that aren't even filled in. This is a piecewise function. So what it basically means is that each graph is like a piece of the entire function. So over here on the right is the function that defines this graph. So we have f of x is equal to x plus 3 whenever x is less than or equal to -1. So essentially what that just means is whenever x is less than or equal to -1, the function's output will be defined by this function over here, x plus 3. So if you look over here, let's zoom in a bit on the graph. We have our point -1 on the x-axis right here. So anything from the left of that, because it's less than or equal to, will be the x plus 3 part of the function. So they will all be defined by x plus 3. Now, when you look at the second part of the function, you'll see that f of x is equal to 3 whenever x is greater than -1 and less than 3. What does that mean? That just technically essentially means that f of x is equal to 3. So the number 3, as you can see over here, whenever x is defined from -1 to the positive number 3. So all the way from -1 to 3, f of x is defined to be 3, which means that the value is just 3, so it's just a horizontal line, as you can see by the purple line on the graph. Now, one important point to note is these two circles over here. Why are they circles and not completely filled in dots? Because x is less than. If you look at the function on the right, you'll see that -1 is less than x. So it's not less than or equal to. And the same thing goes for 3. X is less than 3. It's not less than or equal to. So you're going to leave an open circle. If you look over here on the green part of the graph, you'll see at -1 we have a closed or filled in circle. That's because x is less than or equal to -1. So whenever there's an equal sign underneath your symbol, then you're going to want to close in the bubble. If there's no equal sign, then you're going to want to leave it open. Okay, and now for our final part of the graph. Our final little function here is x plus 4. So we have x plus 4 whenever x is greater than or equal to 3. You can see that it's greater than or equal to, which is why we have a filled in dot over here. If you see, the function x plus 4 defines the rest of the equation all the way from the point 3 on the x-axis all the way to the right. So that's about it for piecewise functions. This is just a little overview of piecewise function. So this function over here on the right, the entire function is how you would write a piecewise function. So if it looks like this, you know that it's piecewise. And over here on the left, the graph, how we can tell is because the graph isn't continuous. A continuous graph is like a graph that either goes like this or a graph that goes like this without ever breaking. But this graph has breaks. See, there's no value over here, and there's no value all from here to here. So this is a piecewise graph because it's discontinuous. There are breaks in the graph, and you can't draw it without lifting your hand. That's one other way to think about it. So for piecewise functions, this is all you'll need to know. A lot of cases, you'll be given a graph and asked to write a function, or you'll be given a function and asked to draw a graph. So let's do another example. So now this is going to be our first example. We have a piecewise function on the right stating that when f of x is equal to x plus 1, whenever x is greater than -3 and less than or equal to 1. So then the next part or piece of the function would be f of x is equal to 3 whenever x is greater than 1. So these are the two parts or pieces of your graph. We don't have 3 like last time, but we have 2. So the first step you're going to want to do when graphing this sort of piecewise function is to draw a table. It's generally the easiest way to figure out what points you need to plot on your graph. So to figure out the x values for the table, you're going to want to look at your piecewise function. So here you can see that x only goes from -1 to 1 in the top part, and on the bottom part, x goes from 1 and beyond because its x is greater than 1, so it's anything above the number 1. So let's start with the lowest value. As you can see, the lowest value we have is -3, so let's put -3 over here. If we're going to put -3, which part, is it this equation or this equation, do we substitute this -3 into? Since -3 is included here, we're going to substitute it into this equation. So we're going to put -3 plus 1, which is equal to -2. I just substituted -3 in place of this x in the first part of our graph. So next, let's take another number. Let's take a number in this interval, so between -3 and 1. So let's take 0. So if you put 0 in your table, we have to substitute it in this function because it's between -3 and 1. So it's going to be 0 plus 1, and it's equal to 1. Let's do another one. Here you know that x is less than or equal to 1 on the top part of this function. So we're going to substitute 1 instead of x, and it's going to be 1 plus 1, which is equal to 2. Now, next, on the next part of your piecewise function, so this bottom part, you see that x is equal to 3 whenever it's greater than 1. So you can put 1 here and write 3 over here. Even though we already have 1 and 2 here, technically x isn't equal to 3, which is why when we draw this on the graph, we're going to use a not filled in bubble. So we're not going to fill in the bubble or the dot that's on the graph. So let's graph this one by one. We have our points over here. We have -3, -2, 0, 1, 1, 2, and 1, 3. So we're going to plot those points on the graph, filling in the bubble as necessary. Okay, so let's plot in our first point. Our first point will be -3, -2. So we're going to plot that right over here. Now that's going to be an open circle because if you look here on the top right, x is greater than -3. It's not greater than or equal to. So we're going to leave it as an open circle. Let's plot our next point, 0, 1. Now x is equal to 0. So because in this interval, x equals 0 is not included, so it's in the middle of the interval, we will include that. So 0, 1 comes around here, and we're going to leave a dotted line for that. Our next point is 1, 2. As you can see by our top interval, x is less than or equal to 1, so we are going to fill in that circle. So we're going to plot x as 1 and y as 2 and fill in that circle. Now if you see, when we go to the next part of our piecewise function, which are the points 1, 3, we have a jump. X goes from being 1 to being 3, but x isn't technically equal to 3 because x is greater than or equal to 1, so we're not going to include this 1, if that makes any sense. So let's use a different color for that, and let's plot that point. So it's going to be 1, 3 when it's technically not equal to 3, so we're just going to leave an open circle. And we know that x is equal to 3 for any number above 1, so that line is just going to continue like this. If we connect this part, our line is going to be something like this. So this would be the final piecewise function. So if you can tell, this is a function because it passes the vertical line test, where if you draw a vertical line, it never crosses more than 2 points. Even if you cross it or draw a vertical line on the point 1, it only crosses 1 point since only 1 is technically shaded in. This other one is just there to help guide us. So that's all there really is to piecewise functions. It can seem a bit more difficult if you get harder equations, but for now, this is all you need to know. It's really easy, and the only thing you need to make sure of is whether you fill in or don't fill in the dot that you draw. Don't fill it in if it's just a less than or greater than sign, and fill it in if it's a less than or equal to or a greater than or equal to sign.